right, today we are going to be talking about searching algorithms. So, two of the largest categories of algorithms for arrays or array lists are searching and sorting. So, searching is going to involve finding the index of an element in an array or an array list or some kind of collection, where sorting is going to be putting that sequence in order somehow. There's lots of different ways to accomplish both of these things, but today we're going to start with a very, very simple searching algorithm. Next class, we're going to talk about a couple of different sorting algorithms. Now, why would we ever want to make a searching algorithm? Well, searching is incredibly useful. We might need to find a friend's name in a phone book. We might need to find if an item is in stock at a store. We might need to check if there is an item in an array at all. So searching lets us determine where things are or whether they're present at all, which is always going to be helpful. So we're going to use array and array list traversal. We're going to use some loops to perform the very, very simplest searching algorithm, which is called linear search. This algorithm is very straightforward. It's very linear. All we need to do is look through every element in an array or in an array list. And if the thing that we're looking at is the thing we're looking for, hey, we found it, we can return its index. So if I made a method called linear search, let's say I want to find an integer inside of an array of integers. We're going to loop starting I at 0 up until I is less than our nums.length. So we're going to loop up through the entire length of our array. And we're going to see, is the thing we're looking at, is nums at index I equal to that variable we're trying to find? If they are the same, we can return I. And if we've reached the end of our for loop without ever having returned I, we can return -1 saying, hey, we did not locate this element. So that is the entire algorithm. It's very simple, like I said. This is one of the easiest algorithms to remember how to do, because all you need to do is look through every single element in your array. So if we do a brief little example, let's say I want to find 1 in my nums array, which is 53191. So which index should we expect to find 1 at? What should this method return if we call it on this array?
Two.
Correct. We should find index 2 because that's the first place where it's going to occur. So if we run through, I starts at 0. We're going to check, is the thing at index 0 what we're looking for? 5 is not the same as 1. So we're going to increase our I. Is 3 the same as 1? No, it's not. I increases. Is 1 the same as 1? Those two things are the same. So we will return 2. And there we have it. Super duper simple. And we can extend this algorithm. We can use an array list of integers rather than just a single, or rather than a regular array. And this should be nums.size. I did not adjust that. That was my fault. But overall, the difference between an array and array list for this algorithm, very, very low. Wow. Once again, did not fix that. Should be size instead of length. But we can apply this to strings. We would just call the dot equals method instead of using an equals equals. We can even do linear search to find whether or not a character is in a string. if we have a string word and we have a string that we want to find, we can get each letter in our word using that word.substring from I to I+1, get the current letter, and if letter equals what we're trying to find, we can return I. So this will work for any kind of collection of values, because strings are a collection of characters, and then an array and an array list are both collections of whatever type of data we say we want to store. So linear search is, as I'm sure you can see, very, very simple to understand and very simple to implement. However, it is not a very efficient algorithm. If we think about a best case scenario for an array for trying to find something, let's say my array is 1, 3, 9, 8, 5. And let's say I want to find the number 1. This is the best case scenario for this algorithm because 1 is the first thing. I need to make one comparison, and hey, we can return it immediately. We found it immediately. Now, in our worst case scenario, the thing we're looking for could be our last element. We could be looking for 5, or we could be looking for something like 6. 6 isn't in the array list at all, so we would have to look through every single element. We have to go one by one, looking through all of them, checking, is this what I'm looking for? Is this what I'm looking for? Is this what I'm looking for? Through the entire array. And if we never find what we're looking for, we look through absolutely everything and to find, hey, it does not exist. So as the size of our data set increases, the number of operations that are likely to be performed are going to increase linearly. As my list or as my array gets longer, I'm going to have to make more comparisons in that worst case scenario. So just something to think about when we're analyzing how efficient algorithms are is as the input size increases, how many more operations do they have to perform? All right. This is a very short lesson. That is it for searching. Sorting is going to be a little bit longer. It's going to be more in depth. So look forward to that next time.